Page 181 in your textbooks. Page 181, we did the review, numbers 11 through 14 at the bottom of the page. And practicing adding polynomials together. And we need to remember that when you add polynomials together, you can only combine terms that are like to each other. So number 11, when you combined the like terms together and wrote the answer hopefully in descending order, Dylan, what did you get for your answer?
7x squared negative 10x negative 1.
7x squared negative 10x negative 1. Number 12, what did you get, Lana?
Negative 16x positive 10.
Negative 16x positive 10. Number 13, Adam. Number 13, what did you get? Adam, read the answer.
I got x to the 12th power by 20.
I'm guessing so. How about you? What did you get, Joshua?
2x negative 11y.
Close, Dylan.
2x positive 11y.
2x positive 11y. When you get your y's together, you have a positive 6, a negative 2, and a positive 7. Get the positives together for positive 13. Put that with the negative 2, but keep the sign of the greater, positive 11y. Let's go back to Adam for redemption, number 14.
I did the wrong 6 on that. I did the 185.
Instead of 181. Oh, Adam. Number 14, Lana.
Negative 2x.
Make sure we follow directions, Adam. All right, turn over to page 91 now. Page 91. Anyone 4 for 4? 4 for 4. Obviously not Adam. Just besides the one side. All right, page 91. Negative 2x. Page 91, you had a couple word problems here to do. Numbers 51 and 53. Read number 1 or 51 for us, if you would, Joshua.
Find 3 consecutive numbers whose sum is 51.
All right, we talked about consecutive numbers, and we said that if I want to represent just any old number class, I would call it x. But the next consecutive number would have to be
X plus 1.
and then the next number,
X plus 2.
and the next number,
X plus
and the next number,
X plus
and so on and so forth. But I get to stop after the third number because it says find 3 consecutive numbers. How many represented your 3 consecutive numbers thusly? Question, Adam.
Oh, no, wait.
Word problem 51.
Oh, I didn't do that.
What did you do?
I did x plus 1, x plus 2, x plus 3.
It works. You'll get a different equation and a different answer for x, but your 3 actual answers will be the same as ours. But if we use this, which is the easy way, because it gives you smaller numbers, and I like smaller numbers because I'm lazy, what would our equation be since it says that the sum is 51? Lana?
3x plus 3 equals 51.
There we go. Of course, you would have had 3x plus 6 equals 51. We'll subtract the 3 from both sides to get class 3x equals 48. And that'll end up getting us x is equal to 16, which means our first number is 16. Now, Adam, you got x equals 15. But when you did x plus 1, it still gave you 16 as your first number. Our next number class, of course,
17.
and then the final number, 18. How many had 16, 17, 18? Put the 3 numbers on 51. You should have gotten the same if you had x plus 1, x plus 2, x plus 3. Be careful on your algebra. Number 53, read that for us if you would, Adam.
The product of, wait, 53?
Yes.
Oh, okay, good. The product of 2 times the sum of the number and 5 is 18 was the number.
All right, how many unknowns do we have this time, Adam?
2. Wait,
What are they?
Wait, the difference between 2 numbers is 8. What? I'm like, the product of 2 times the sum of the number.
Make sure when we read it the first time we read and think about what we're reading.
I don't have, isn't there only one?
There is only one unknown. It's the number that they're asking for. And if there's only one unknown, class, we're always going to represent it x. And so the entire word problem just becomes what, Dylan? Algebraic representation. How did you algebraically write out word problem 53? Adam?
The quantity x plus 5. That's all I put.
Well, there's a whole lot more than that. Dylan?
2 times the quantity of x plus 5 equals 18.
There we go. It says the product of 2 and this, or times the sum of a number and 5. There's the sum of a number and 5. 2 and the sum of a number and 5 are being multiplied. The product of 2 times the sum of a certain number and 5 is or equals 18. How many have the same equation? that Dylan had. Questions on that?
No.
All right, and then to solve, what should we have done last night had we had the correct equation? Adam?
Distribute 2x plus 10 equals 18, and then subtract 10 by, you get 2x equals 8, and you get 4.
There we go. So the answer is 4. That is our number. How many had 4 as the answer to the word problem? Questions on that? We're going to get back to your homework here in just a moment, but for now, let's take a look at the word problem that is on the screen. And let's have Joshua read this word problem for us, please.
The Canadian Falls and the Niagara River are 158 feet high. This is 8 feet more than 10/11ths of the height of the American Falls. Find the heights of the American Falls.
All right, so obviously Niagara Falls, which is what we normally refer to it as, has two sides, right? There's part of it on the American side of the border, part on the Canadian side of the border. And so we've got these two different falls, if you will, within the Niagara Falls. How many unknowns then in this problem, Joshua?
3.
What are they?
Canadian Falls, Niagara River, and
Well, the Niagara River is where these two falls are located. Collectively, we call it Niagara Falls.
American Falls.
And that's actually it.
Yeah.
Just the Canadian and American Falls.
I
All right?
saw it at first.
All right, does it make sense now? All right, and which one of these should we pick to be X?
American Falls.
Right, it comes back to the American Falls, 8 feet more than 10/11 of the height of the American Falls, so we'll let the American Falls be X. How would I represent the Canadian Falls height, Joshua? 10/11ths X plus 8. How many thinking the same thing Joshua said? All right, questions on how and why he set it up this way. All right, and once we've represented our unknowns, the next thing we want to do is set up our equation, right? And to set up the equation, we need to figure out what number hasn't been used yet. Dylan, what number has not been used?
158.
All right, is the 158 feet the Canadian? Is it the American? Is it both of them together?
The Canadian.
That's the Canadian Falls. The 158 feet is not the total height of the falls. That's just the Canadian side. And once again, we see something we saw a couple days ago where we have one unknown represented two different ways. And I had you write this in your notes. If you have one unknown represented two different ways, the equation will always be the two ways equal to each other. Logically, that should make sense. How high are the Canadian Falls? 158 feet. How high are the Canadian Falls? 10/11ths X plus 8. It's both of them, right? And since it's both of them, they must be equal to each other. So the equation here, 10x over 11 plus 8 equals 158. Does it make sense? Questions on this? Besides the fact that there's a really weird fraction.
Yeah.
All right, now, normally if I have an equation with fractions, I think, oh, I hate fractions. And so I get rid of the fractions and I multiply everything by the LCD, which would be
11.
But I'm lazy, I don't want to multiply 11 times 158. Y'all with me there? We don't want to do that either? All right, so there is a way we could get around it. If I could get this by itself, I could multiply by the reciprocal instead, right? But because of the 8, I can't just say, well, let's multiply by the reciprocal. Well, what if I got rid of the 8 by putting a negative 8 on both sides? Well, now I've got a 10x over 11 all by itself equal now to,
158.
which is,
150.
150, because we subtracted the 8, correct? 150 over 1. And now if I multiply by the reciprocal class, which is 11 tenths,
Yeah.
thoughts on how this suddenly became a whole lot easier than it looked initially?
Yeah.
What can we do?
Cancel the 150 and a 10.
Yeah, I can cancel the 10 with the 150 to get 15. And so instead of multiplying everything by 11, I just multiply 15 by 11.
Oh.
151.
Multiply it out.
165.
There we go. Adam multiplied it. I got 165. So apparently 165 feet is the height of the American Falls, and apparently the American Falls wins. Haha. USA. USA. Anyway, all right. So American Falls. Not that I'm competitive or anything. All right, ours are higher. Just saying. All right, questions on this?
It's actually higher than Niagara.
It's part of Niagara Falls.
I keep
Our
I
part.
mean, there's Niagara Falls is a big kind of a curved shaped waterfall. Part of it on the American side, part of it on the Canadian side. So we got the American Falls, the Canadian Falls, and it's all Niagara Falls where people like to go for honeymoons or go over in barrels to see if they can survive it. Which is just weird. Yeah, I've never heard of that. People going over Niagara Falls in a barrel and see if they survive the crash.
No.
I wouldn't do it personally, but yeah, it's apparently a thing.
Oh.
And then people like, tightrope over the river and see if they can ride a bicycle across the tightrope and walk.
No.
I'm like, see,
That's stupid.
I'm like,
suicide.
just to get in like some world record book, I don't care that much. I'd rather be alive than famous.
Right.
But anyway,
Exactly.
I mean, there's one way to get your name in the paper, that's by being in the obituaries. I don't feel like that, I don't need my name in the paper that bad. All right, questions on this word problem. The main thing to take away from it again, when you have one unknown represented two different ways, class,
They are equal to each other.
set them equal to each other. All right, questions on that. Let's get back to the homework now, and back to page 185 now. Back to page 185. We'll continue looking at word problems, as I mentioned yesterday, in each of our lessons. Continue looking at several word problems each time. Page 185. And yesterday we talked about multiplying monomials, and I said there are 3 steps to multiplying monomials, class. What are those 3 steps?
Sign, number, letters.
Sign, number, letters. With the sign, I said if the signs are the same, class,
You're adding
Years.
At positive.
you get a positive. And if the signs are different,
You
you get a negative. Now, if we were adding terms together, but anyway, more multiplying. Now, what if I had multiple monomials all being multiplied together? Then I'd have possibly multiple terms. Then we'd go with the even odd rule, right? If I have an even number of negative terms,
Then it's a
positive, and if I have an odd number of negative terms, I would get a
negative.
right? We said as far as the number goes, just multiply the numbers, but when it comes to the letters, they're very important. Told you to put a star next to this in your notes. When you multiply like bases, class, you add the exponents, and that's what you were practicing with on page 185. You did just 4 problems on this page, numbers 2 through 8, the even. Number 2, what did you get for your answer, Adam?
Negative 25x to the 4th.
Very good. Number 4, that was negative 25x to the 4th. Number 4, what did you get, Lana?
Negative 16y to the 6th.
Negative 16y to the 6th. Very good. Number 6, Dylan.
Negative 21x squared y to the 4th.
Good. Negative 21x squared y to the 4th. And the number 8, Joshua.
21x cubed y cubed z.
Great job. 21x cubed y cubed z. How many got 4 out of 4 correct there? Excellent. You can set your books aside for just a moment, and I got a couple classwork problems for you as we continue to practice with this. Interesting, so I want you to multiply those monomials together. Anna's finished. Adam's finished. Oh, sorry, Scott, I didn't see you. Scott's finished. Dylan's finished. Joshua's taking forever. All right, we'll go to Joshua on the last one here in a moment. As we look at the first one, class, there's multiple terms. So I'm not thinking so much same, different rule as I am even, odd rule as I think through my 3 steps.
Sign,
Sign,
number,
number,
letter.
So with the sign, I've got 2 negatives total. Class, that means my answer is going to be positive because that's an even number of them. As far as the numbers, I just multiply 3 times 4 times 5. 60. And then I'm going to come to the letters, and I want to approach them alphabetically. The first alphabetical letter I see is M. I've got an M squared and an M to the 5th. Class?
M to the 7th.
M to the 7th, because when we multiply like bases, we
Add
add the exponents, we come to the N. I've got an N, I've got an N, and I've got an N cubed.
M to the 5th.
N to the 5th. 1, 1, and 3 adds up to 5. And I've got a Z and another Z.
Z squared.
Z squared, because 1 plus 1 is 2. How many got positive 60? M to the 7th, N to the 5th, Z squared. On the next one, Joshua, what's my sign?
Negative.
My number?
16.
My A ends up being,
8B.
my B ends up being,
B cubed.
and my C ends up being,
C to the 8.
and we're done just that fast. All right, questions on this? All right, next thing in your notes. We're going to kind of piggyback on this idea as we go to raising a monomial to a power. Next section in your notes, raising a monomial to a power. Of course, you understand that when you raise something to a power, that's just another way of saying you multiply it by itself a certain number of times, right? So if I were to have, for instance, x cubed squared, well, that's just another way of saying x cubed times x cubed, right? And we multiply x cubed times x cubed, class, we get
X to the 6th.
x to the 6th. Or if I had m squared to the 5th, well, that means m squared times m squared times m squared times m squared times m squared, which is a really inefficient way to do this, but we understand that's what that means. Well, what is m squared times m squared times m squared times m squared times m squared?
M to the 10th.
M to the 10th, we add up all those 2's. But there's a much more efficient way, right?
Yeah.
The quicker way would simply be to do what with these exponents, class?
Multiply.
Multiply them. So write that in your notes if you would. When you raise a power to a power, multiply the exponents. To raise a power to a power, multiply the exponents. To raise a power to a power, multiply the exponents. But what if we had, for instance, an entire term or something like a negative 10 x squared y that's all being cubed? For instance, I said raise a monomial to a power. 3 steps, get these down. Number 1, sign. Number 2, number. Number 3, letters. Sound familiar?
Yeah.
Of course, because this is another way of multiplying. So of course the steps are going to be the same. Sign, number, letter. Our rules vary just a little bit. For the sign, we need to know that a positive to any power is positive. A positive to any power is positive. You keep multiplying a bunch of positives together, your answer is still going to be positive. A negative to an odd power. Well, let's think about it. That means we would have a negative times itself an odd number of times, right? And we said an odd number of negatives gives us a
Negative.
so an odd power of a negative would also give us a negative. And then finally, a negative to an even power will give us a positive. So for your sign, it depends on what the sign is, what the exponent is. If it's a positive, it doesn't matter what the exponent is, it's always going to be positive. If it's a negative, you have to ask yourself, is this an even power or an odd power? Odd power is going to produce the negative, even power is going to change it to a positive. For the number, and this is important because some students will look at this and be like, oh, 10 times 3, that's 30. No! 10 cubed does not mean 10 times 3. Class, what does 10 cubed mean?
10 times 10 times 10.
We're going to use the number as a factor. Use as a factor that many times, meaning whatever the exponent is. Use as a factor that many times. So not 10 times 3, but 10 once, times 10 twice, times 10 3 times. By the way, not 3 multiplications. Some students have fallen into that trap. They'll say 10 times 10 times 10 times 10. No, you count the tens as factors, not the number of multiplications, but the number of factors. 10 once, 10 twice, 10 thrice. It's a good word we don't use often enough. All right, and then as far as the letter goes, to raise the power to a power, multiply the exponents. You write it down again. I'm lazy, but you don't get to be. All right, raise the power to a power, multiply the exponents. By writing it twice, surely there is no way you can screw this up, I tell myself. All right, letters. To raise the power to a power, class, as you're writing it,
multiply the exponents.
Multiply the exponents.
For the letter?
For the letters. Because letters will have powers. Variables, which is the proper word, but I'm too lazy because it's too many syllables. Variables will have exponents on them, even if it's an understood 1, like we see on the y here. So all variables have some power already, and you're raising those powers of the variables to a power, so we're going to multiply those exponents together. So here, let's take it through. Sign, number, letter. What should the sign of my answer be, class?
Negative.
Negative, because it's a negative to an odd power. What is 10 cubed?
1,000.
1,000. 10 times 10 times 10 is 1,000. And then when they come to the letters, x squared cubed, class becomes
X to the sixth.
x to the 6th. And y to the first cubed becomes
Y cubed.
y cubed. Because when you raise a power to a power,
Multiply the exponent.
multiply the exponents. Write this one down. 4 m to the 4th, n cubed, z to the 6th, all raised to the 4th power. 4 m to the 4th, n cubed, z to the 6th, all to the 4th power. My 3 steps, class, are
Sign, letter, number. Sign, number,
Sign,
letter.
sign, number, letters. So with my sign, what should my sign be?
Positive.
Positive. And I can leave it understood positive, can't I? It's understood positive, leave it understood positive. Then for the number, I need to raise 4 to the 4th power at your seats. Figure out what that is. Call it when you've got it.
256.
Good, Adam, 256. And then with the letters, I'm going to raise powers to a power. I need to multiply the exponent. So I'm going to get m to the 16th, n to the 12th, and z to the 24th, because I'm multiplying the exponents. All right, questions on this? Aren't you glad it's a z and not like a 5 where you have to figure what 5 to the 24th is? You just leave it as z to the 24th, which is awfully nice. All right, no. All right, write this one down. Negative 9 r cubed, s to the 5th, t to the x, all squared. Oh, a literal exponent. An exponent that is a letter. Remember, literal always refers to letters in mathematics. We have a literal exponent here. Don't let that throw you off. You follow the steps. You aren't fazed by anything. You know your 3 steps are.
Sign, number, letter.
And when you take care of your sign here, class, you're going to get?
Negative 80.
Oh,
Positive.
a positive, because you have a negative to an even power.
Oh.
It's going to become positive. What about the number?
81.
81, good, not 18, it's not 9 times 2, it's 9 times itself, 9 times 9. And then with the letters, we said to raise powers to a power.
Multiply the exponents.
So here, Josh, I'm going to get r to the
6.
6th. Dylan, I'm going to get s to the
Fifth. No, x to 10.
10th. And then what about the exponent of the t, class?
2x.
2x, because you just multiply. 2 times x, it's 2x.
Oh,
And there we go.
That's weird.
We're
that's
done.
our answer?
That's our answer.
Weird.
Positive 81, r to the s, or r to the 6th, s to the 10th, t to the 2x. What if I had an m to the 3r minus 4, all raised to the z power? Well, I get m to the, let's see, we have to multiply 3r minus 4 times z. Well, that'd be 3rz minus 4z. It looks really weird, and you feel really smart doing it, but there's your answer. Yes, sir?
Couldn't you write m to the z times the quantity of 3r minus 4?
I suppose you could. We generally like to distribute, remember? Right? So, but yeah, you could. All right, questions on this? Most of the time you're not going to have them quite like this. But just pointing out, the steps never change. It's the beautiful thing about mathematics. Always the same steps, even when it looks goofy.
We don't look
Alright.
like nerds.
And you feel like a nerd. I mean, like a really smart person. All right, page 185. I want you to do 9 through 23, the odd. Back to page 185, doing 9 through 23, just the odd. I want to make sure we are correct before we go back and hit those evens. So do not do the evens yet. Just 9 through 23, the odd numbered problems. Let's go and take a look at these together. And number 9. What did you get for your answer, Adam?
X to the 6th.
X to the 6th. Number 11, Dylan.
Y to the 50th.
Y to the 50th. Number 13, Joshua.
X to the 12th.
X to the 12th. And the number 15 is a fun one because we have to raise z squared to the 4th first, and then cube that. What do we end up with, Lana?
Z to the 24th.
Z to the 24th. Very good. Number 17. What did you get for your answer, Dylan?
2x to the 6th.
Well, you're right about the letter. X squared cubed is x to the 6th, but you forgot to cube the 2. 2 times 2 times 2 should have given us 8x to the 6th for our answer. Number 19, Joshua.
Negative x to the 8. Wait, is it negative 3x to the 8?
Well, the sign is going to be negative, correct? What's the number right there?
1.
A 1, and when you cube a 1, 1 times 1 times 1,
1.
still 1. And then when we raise the power to a power, we
Multiply it.
so we end up with
Negative x to the 8.
multiply the exponents. What's 5 times 3?
Oh, 15.
Negative x to the 15th should have been our answer there for number 19. Does it make sense now?
Yeah.
All right, number 21, Adam.
X to the 8th.
Positive 1, x to the 8th, or we could just say x to the 8th, because we can leave the positive understood and the 1 understood. So I like your answer best of all, Adam, x to the 8th. Number 23, Lana.
25x to the 10th.
Good, positive 25x to the 10th is correct. All right, we had a little trouble here and there at times. Do we feel like we understand what we're doing now? All right, look at number 25, and what would we get for our answer on number 25? Do it very quickly. And then we'll get our answer from Lana once she's got it.
Negative x to the 12th, y to the 6th.
Good, negative, because it's an odd power, a negative raised to an odd power, I should say. The 1 cubed, of course, is just 1. I like that she left it understood. And then x to the 12th, y to the 6th. How many have that same answer? What did you have, Adam?
Actually, I got positive x to the 12.
Does it make sense there? Again, the odd power, the cube on the negative leaves it as a negative. Look at number 27 with me. We've got a 2x squared y, quantity cubed, times a 3x squared. Do you see that there's two different operations going on here? I've got an exponent and I've got a multiplication. Which one should happen first, class?
Multiplication.
Exponents always happen before multiplication. Remember, it's parentheses and grouping symbols. Exponents, multiply, divide, add, subtract. So before I can do the multiplication, I need to simplify here. What will I get here, Dylan?
8 x to the 6th, y to the 3rd.
Good. And then I can now multiply that by the 3x squared. But now we're multiplying. Now we're not raising to a power. But we just still do sign, number, letter. But now sign, class,
A positive.
number
24.
24 as we multiply. And then remember, when you multiply like bases, class, you add the exponents. Here we were raising a power to a power. We multiply the exponents. Now we're multiplying like bases. Now we add the exponents, Joshua, to get...
X to the 12th.
Careful, we're adding the exponents now.
Yeah. X to the 8th. And y cubed.
Good. And you see how this is going to develop mental dexterity, a little bit of mind flexibility, if you will, the ability to go back and forth between processes and stay focused on it at the same time. Multitasking. Very good helping your brain with that. But that's what's going to be required here. Look at number 29. This one's nuts. We've got an x squared y, quantity squared. We've got an xy cubed, quantity squared. We've got to multiply them. And then we've got all of that being cubed. So a lot of back and forth here. But again, to help your brain develop to be able to do what it's going to need to do as an adult one day. So we're going to start. I've got power on the outside. Remember, we always work inside first. So here I've got a power, a multiplication, and a power. What should I do first, Lana?
Power.
The powers. I'm going to take care of both of them, and the multiplication is going to have to wait. And then since this cube is on the outside, that's going to be the very last thing I do. So I'm going to end up with two things multiplied. Whatever x squared y squared is, and whatever xy cubed squared is, that's what's going to go here. What is x squared y squared, Adam?
X to the 4th, y to the y squared.
There we go. And what is xy cubed squared, Dylan?
Xy cubed squared.
Or number 29. We're trying to simplify right here, Dylan. You can look at the board. I'm trying to square an xy cubed. What do I get?
2 x to 2
So we say x
squared.
squared.
And y to the 6th.
There we go. First step, don't make it hard. Multiply the exponents because you're raising powers to a power. You're raising powers to a power. Multiply the exponents. But now, I need to multiply these two monomials. And when you multiply like bases, class, you add the exponents. So back to adding the exponents now. What do I get here, Lana?
Xy to the 6th.
Well, take the x's first. What do I get?
X to the 6th.
Then take care of the y's.
Y to the 8th.
There we go. Does that make sense? Now we have to raise all of that to the third power. So now we go back to raising powers to a power class. Now we're going to multiply the exponents. What do we get now, Joshua?
X to the 18th. Y to the 24th.
There we go. Following order of operations and being able to use both rules of exponents that we talked about yesterday and now today alternately. Does that make sense? Requires focus. Okay, do you hear a strange sound? It's like, I thought I heard a weird sound. Some sort of alarm going off. Anyway, it's not our fire alarm, so I guess we're not burning yet. All right, questions on this? Questions on this? All right, I want you now to do numbers 10 through 30, the even. 10 through 30, the even. Okay, Scott, I just got your mom's email. She sent your quiz in so I can grade it. It says also, he asked me to let you know that he beat all of them. I assume you will know what that means.
He beat all of us. Of course he did.
Just wanted to make sure we knew. But let's see if his grade.
Oh, yeah.
Yes,
Scott.
God.
Yes,
Alright.
Scott.
We're not competitive or anything here.
Yeah,
Shh,
Scott.
quiet so I can focus. You wouldn't want me to miss any of his wrong answers. They're not competitive or anything, Scott. All right, Adam, you'll feel better about this. He forgot his dollar signs too.
Oh, good.
Ooh.
That was your only mistake though, Scott. So, 99.
Wait, where's the dollar signs again?
On the word problem, it was money.
Yeah.
Oh yeah, I didn't even finish that, so.
Dylan was the only perfect 100 in the class?
I knew.
He'd be like, take that, Scotty.
Yeah, take that, Scotty. I'm done anyway.
Scott always missed problems because he went too fast.
Well, I go too fast and I get 85% of it
He
right.
probably already is skipping the video because he's done.
Well, evidently not, because remember we were joking yesterday he was already skipped ahead, and he evidently didn't because he heard what we were talking about and asked Mom to reply in.
So he did skip it.
He did not. No, indeed.
Because he wanted to hear us talking.
Good boy, Scotty. He's probably already done before us.
He's been done long ago.
Is his answers right though?
Probably
Is
not.
his answers? You mean are his answers?
And
Probably
failure.
not. His answers are probably wrong.
Should have never faith in your uncle.
I need to meet. I need
No, I
to
know.
meet Scott face to face.
Oh, I have.
Hopefully next.
I've met him.
You guys met.
All
Scott.
of us have met him.
I haven't.
Except you. You'll know him eventually.
He's a good
Don't
kid.
know
He just
about
has a
that.
tendency to break his arm before endurance runs.
Yes, Scott.
Well, he breaks it.
Cause he was being.
He was being a dummy.
Oh,
You're just jealous because
You know he has
jump
authority
as high and
over you,
grab
right?
over that.
I don't want to jump that.
Lana, he's your uncle. He has authority over you.
No, he doesn't. I don't
All right, be quiet and work. Scott's sitting there waiting for y'all to finish, and Dylan's sitting over here waiting, and I'm sitting here waiting. Let's mush. Chop, chop.
Chop, chop.
Take one more minute, and then we'll go over them. See how far you can get in that 1 minute.
Done.
Shh. Not talking to you. All right, let's go and take a look at these together. And number 10, what did you get, Joshua?
X to the 6.
Good, x to the 6th. Number 12, Dylan.
Y to the 50th.
Y to the 50th is correct. Number 14, Adam.
X to the 12th.
X to the 12th is correct. And then number 16, we have to start by cubing the z to the 4th, and then squaring what we get from that to get what answer, Lana?
Z to the 24th.
Z to the 24th. Anyone feel like your intelligence was slightly insulted?
Wait, is it the same?
Yeah.
It's all the same answers as the odds. They just
Wait,
changed
what?
the order of the exponents, but since multiplication is commutative, it doesn't
I
matter
didn't even know.
if the order of the exponents is
Okay.
changed, because you're multiplying them.
I'm so slow.
All right, number 18. Here they actually mixed it up a little bit, sort of, a couple times. And what do we get for 18, Lon?
9x to the 6.
9x to the 6th. What do you get for number 20, Joshua?
Negative x to the 15th.
Negative x to the 15th. How about number 22, Dylan?
X to the 8th.
Positive x to the 8th. And then number 24, Adam?
36x14.
Try saying that correctly.
36x to the 14th.
There we go. 36x to the 14th power is correct. Let's see. Number 26. We're cubing here. What do we get, Joshua?
Negative x to the 9th, y to the 18th.
Good. Negative x to the 9th, y to the 18th. Number 28, our first step, Lana, is to raise to the 4th and then also cube. So when you raise to the 4th, you got?
X to the 8th, y to the 8th.
Good. Positive x to the 8th, y to the 8th. And when you cubed, you got?
8xy.
You remember to cube the 2 and got 8, but you should also cube the x.
Oh.
Because it's a
X cubed?
x cubed and cube the y.
Y cubed.
Because the exponents were understood ones, right? And then you're raising to the 3rd power, multiply the 1 times the 3 to get the 3rd power. Now, what do I have to do with these two things, Lana? Well, multiply, but with the exponents we'll add, because when you multiply like bases, you add the exponents. What's our answer?
8x to the 11th, y to the 11th?
There we go. Anyone have that answer? 8x to the 11th, y to the 11th.
Nice.
Good, Scott. Good, Dylan. Questions? Does it make sense now? Now let's take a look at the last one. Number 30, Dylan. We've got the xy squared cubed times x cubed y squared to the 4th. All of that squared. Talk me through what we should do in order here.
Take care of the exponents inside the brackets.
Good. Interior exponents first. So we get
X cubed y to the 6th. And then x to the 12th, y to the 8th.
There we go. Okay. Now what should we do?
Multiply.
Multiply inside to get
X to the 15th, y to the 14th.
because when you multiply like basis class, you add the exponents, and now we have to,
Multiply.
well, square, which means we're going to multiply the exponents, because when we raise the power to a power class, we multiply the exponents. And what do we get here, Dylan?
X to the 30th, y to the 28th.
Good. X to the 30th, y to the 28th, our final answer. Anyone else get that answer? Good, Adam. Questions on this?
Going to, but like I knew it was x to the 30th, but for some reason I put x to the 13th.
Careful. Okay, questions? All right, you're going to get a chance to practice with a little of this for homework tonight. Page 188 for homework. Page 188, do the review 3 through 12. Page 188, do the review numbers 3 through 12. And then back on page 91, do word problem 55. Page 91, word problem 55. Again, page 188, review 3 through 12, and page 91, word problem 55. We'll take a look at all of that on Monday. Our exam is coming up on Monday as well in here, and we will see what lesson that ends up being, Scott, for you.
Upcoming Monday, so Monday.
The following Monday, right? Not this coming Monday. Today's Friday, October 1st, as we record. Coming up, not Monday, October 4th, but the following Monday, October 11th.
What's the date for it?
I just said it, October 11th. It's
The
okay.
one on page 188.
Page 188, review 3 through 12. And page 91, word problem 55.
Also, I won't be here October